In today's video, we're gonna learn how to do a cylinder in OpenGL, writing in C++, like this, a stainless steel Xcode. So let's dive right in. For the libraries, I had a detailed description about how to add on the frameworks on Xcode, which are the OpenGL, Glut, Coco, and IOKit framework. If you're interested in that, you can check out that video. And I have put other libraries like the GLAD, the GLFW, which are the two extra libraries that we're gonna use for rendering the vertices, and GLAD is to bridge the windows between GLFW and OpenGL, and also a image library and GLM, the math library. We're gonna need some trigonometry in there, and a file system where you can get access to your local file, and then a shader file. And then of course, if you want to go beyond a cylinder and do other models or objects, then we can create our own models that we're gonna talk in detail in the future videos. But for now, since I put all of this libraries in the include, so it's easy to find here. And let's just go through the beginning of the code. You define the screen width and the height, and there are two functions here. Just one more thing regarding the libraries. If you cannot find the libraries for some reason, or you didn't put it in your project folder, there's another way where you can go to the project, instead of build phases, link library with libraries, you can go to the build settings where there's a search path where you can put header search path over here, add on your path, or the library search paths over here. Okay, and the first one, a frame buffer size callback. This is a GLFW function where it's gonna use the size to create the window or the screen where you define the width and height. And the second function is to process input. This one is to close the window. If escape is pressed, then the window is gonna get closed. And also, if you want to control the camera movements, the WASD, WASD keys, or the mouse input, we can put all of them in here, which we can implement later. And go down to our main function. First, to check if the library has been initialized, and if the window has been initialized, and notice here the 3 means the OpenGL version 3, and we just create the window and put your title of the window here and initialize the window. If there's any failure, then it console log. And this is to set the window. This step is really crucial, where it's gonna call the make context current to make the window, and also the frame buffer to put on the size and the buffer in the window. And next to call the glad library to check if this is included. And the next one, GL enable depth test. This is important because if you have objects that have layers, especially the furthest one, should be drawn like the firstly, so that it won't overlap on top of the near object. Next, we need a shader because we already created a class of shader, so we only need to put the path to these two files. One is the vertex shader file, the other one is the fragment shader file. These two are gonna be executed directly on the GPU. So let's take a look at this two files. And before this, I had a trouble in the beginning where like to let the compiler know where these two files are. So in Xcode, if you go to the project and then on the top, the product, there's a schema and edit schema, and if you and I think by default it's gonna have this options tab on, and then under it there's a working directory where initially it wasn't checked, but it was unchecked, so you can check this box and then put your directories over here so that when this C++ file gets executed, it's gonna find where to find these two files, and you put these two files over in the working directory. So let's take a look at the vertex first. This is similar to C language one. First you kind of initialize the position. It's gonna be a vec3 xyz, and we also need a texture, which is gonna be just two vectors, x and y, and we put in the location y, and we're gonna output a texture coordinate, and we need to use 3 uniform matrix, and we're gonna talk about this 3 later on. But basically, model means how you want to rotate the object, and view is to translate it from this vec3 into a matrix. And lastly, the projection is for the perspective, where almost like where the camera is positioned, like there's gonna be a ratio starting from the camera point to the object, and to define the angle. And again, we're gonna talk in more details later on. And then down in the main function, you want to have the GL position, which is gonna be the projection times view times model and times a vector4, where you put your position, and just gonna be a unit 1.0 float in there, and the texture coordinate is just gonna, you can write down like the x coordinate and y coordinates, or you can just write it's equals to this input of the text coord. Then let's go to the fragment, where it's gonna use the coordinate from that vertex shader file, and it's gonna get to the color of the fragment. Because we're using a texture, so we use a uniform sampler 2D of the texture one. You can also use two textures and then mix them together, but for this one, since we just want the metallic feeling, so we just use one of them and then just put text one, and the coordinate is gonna be the one we generated from the other Vertex shader file. So let's go back to our main file. Next is one of our kind of important part, which is to generate all the vertices for cylinders. As you can see, in like a regular or in the beginning, you can try to write this kind of hard-coded coordinates. But then in a little bit advanced, especially if you want to generate a little bit more, then it's better to use like loops where you can reuse the code. But let's kind of go through the hard-coded ones first. This is to generate a rectangle. So it's gonna be an array which has like 1, 2, 3, 4, basically 4 big chunks of coordinates, and the first 3 is gonna be the vertices, like the position. If you want, let's try, I can use this drawing here. So we can name this ones. If you name it 0.5 f and negative 0.5, well, you can name like any position to be like this, because like the positions are relevant. So if you name one as positive, then the other side will be negative. So it doesn't really matter that much as long as you know like how the points are being drawn. So let's see if this one well, let's just accord to this. I think I made some modifications later on, but just to show you like how, let's say that if we put this one, so you can sort of ignore the comments so you can see it clearer, a little bit clearer. So let's put this 0.5 and 0.5 on the right top corner here. And if the next is negative 0.5, so if the x value goes to negative, so then it should be like this one because the y is still positive. So it goes from that point to this point, and all negative, then it goes down here. And then the last one, oh, actually the first one is gonna be this one. So now you know like how the vertices are located. And the second of this 3 is gonna be like the colors, where you want, you can just use the RGB values for this, because this one we're gonna use texture, so we're not really bothered with this, and we're gonna actually omit this part for our loops there, just to simplify it and because of the texture. And the last 2 will be the texture of the position, yeah, where you want to map it to. And the other thing is the indices. I wanted to show up here, because as you might already know that in OpenGL, or I guess most of the game engines, you actually, if you want to draw a rectangle, you should draw triangles first. So it's always trying to find a triangle first. That's why we need indices, to avoid just writing down the vertices like several times, because if you want triangles, you have to go through like 0.1, 0.2, 0.3, and you want the other triangle, then you have to go through this 0.1 and 0.3 again. So that's why we create indices, which means you use 0, 1, 3. This is the 0, the first one, and 0, 1. Sorry, 1 is like the 1 is the second, and 3 is gonna be the fourth. If you know the index starts from 0, so 0, 1, 2, 3. So we start from 0, 1, and 3. And this is understandable. 0, 1, 3 to form one triangle, and the next 1 to 3 to form the second triangle. So this is basically how it works, but we're gonna make it even faster or clearer, which is where we're gonna use a loop. First, you can put your sides in here, like yes, because remember we're creating a cylinder, but the way you create cylinder is you create sort of a polygon on the top, and if you have enough sides, let's say for example this one is 6-sided, but if you have like 20 or 60, and then you're getting closer and closer to a circle. So we just need to compute like when it's this simple, and then we can scale it up with the sides and then get close to a cylinder. So we create a pointer of an array of float similar to this one, where the size, let's put a 5 here, because like I said before, we only need the 3 positions and a 2 position for the textures. We don't need the colors. So if it has the colors or the normal vector here, then it's gonna be 3, 3, 2. So it's gonna be 8, but we only need 5 because we only need position 3 of this and 3 of the texture. So it's gonna be 5. And a 2 because we have both the top and the base, and then just multiply it by the sides. And then next one, we're gonna create an indices. For the indices, it's gonna be 6 times the sides, because instead of this one, you use 2 indices to form, or like 2, basically it's like 2 kinds of arrangement for a rectangle, but for this one we need 6. If you're using a sides to measure it, then each side you need 6 vertices to form a whole rectangle, if that makes sense. Because like this one, yeah, I think it will get a little bit easier for if once we get down to the code, but basically this means for a rectangle you need 1, 2, 3, 4, 5, 6 of the indices, or I should say 6 indices to form a rectangle indices array. Yes, because you need 6 of the vertices. It's just maybe like 2 of them are duplicated, but you need 6 of them, and just times the sides. And next thing is what's gonna involve a little bit of high school math here. where you remember we have actually this is not totally angle, because angle is when you refer to degrees, but here we actually want to use the radian just because we're gonna use the cosine and sine, and they are using radian. So it's basically like the degrees, if you're familiar with 360, 180, and you just use the corresponding is 2 pi and pi for it. So to make this thing a little bit easier to explain, let's use a polygon. In this case, a hexagon, for example. So on the top of the cylinder we're trying to build, and also the base, you want to have a circle, and the way to determine the coordinate of the circle is let's say for this one we want decide the x and the z value for this point. So you have the radius r and an angle or a radian of theta. So the x coordinate should be the r times the cosine over here, and the z value is going to be the sine over here. And this is the first point, and then as you go over to the next point, you are gonna need to time, as you can already see a little in our loop. But basically if you go to the next point, you're gonna need the same, just the angle should be like the corresponding arc length. So instead of this theta, you're gonna have the corresponding whatever arc that you have. So it's actually gonna be theta times the I. So if it's just 1, then it's theta times 1, and theta times 2, and go on and forth. We're gonna make it a little bit easier if we go down to the code, but basically the math part of it is gonna be because you want to use, let's see, the whole from the center, the whole degrees are 360 if you're more familiar with degrees, or you can say it's 2 pi. It's the same just in terms of radian, and you divide this by the sides and you get this theta value, which is how many, like for each pi, each slice from this whole circle, this is how much or the individual ones you get, and times n refers to like how many of them you will have. I hope it makes sense to you, and I also have drawn like a cosine curve, just it's not that accurate, actually not at all, but just in case you are not that, you don't remember that much, but this is from the pi, from 0 to pi and to 2 pi, and the cosine value goes downwards here and then goes upwards until here again. Yep. If you're interested in math, you can check out the math videos too, but let's dive into the code and see how it's implemented here. So we define this angle to be 2 times pi over the sides, which is gonna determine our theta, and define a value for the radius. So we're gonna have a loop to iterate from just one side to two sides to all the sides, the maximum one, and for the indices of this and this vertices array, we're gonna use for the top, we're gonna use 5 times 2 times I. Hope you understand this for now, because we have remember before, as we had like 5 vertices, and we have top and base, and then just times the sides to get to each vertices. And the base is gonna be top plus 5, because once we're done with the top, the ones, and then the base is just gonna be right after it. So for the first one, we want to put the, remember the x value is the cosine here, so we put the cosine times the radius, and this is going to be the y value. For our case, the y values are the same, and sine for the z value here, and this two are for the textures. Remember the these 3 are for the vertices, and these 2 are for the texture. So the third and fourth are for the texture, where for the top we're just gonna give the 0f, and for the third position in the top, or the first of the texture, is gonna be I over sides, which is, if it's a hexagon, and it's gonna be 1/5 and 2/5. And also a similar thing to the base, except the y value is gonna be negative because it's at the base in terms of the top one. Okay, and now we just go down to our indices, where we wanted to have the triangles to be separated by every 6th of them, because like we said before, there are gonna be 6 vertices, and we want the vertices to be separated by every 2 of them. And then we want to set another variable, which also is gonna be jumping like by 2. First we just define the ending conditions. When it gets to the last one, then it's gonna stop at 0. But otherwise, as you can see, you can actually generate your own indices, because what really matters is you connect these dots. So it doesn't really matter that much, not that strict as to how you connect them. For example, this one, you connect a first one, 0 over here, and then the second one's gonna be 1, and then the third one. So 0, 1, 3. You connect this 3 first, and then you connect 1, 2, 3. You connect this 3 first, because remember, we're in a loop, and then it's gonna go straight. Next it's gonna like increment by 2. So for the next loop, it's gonna start from this 2, 3, 5, and then 3, 4, 5. So it's gonna be iterating through all of them, as long as you put all the indices in there. We want to make sure that we can have all of them, so you can keep experimenting until it works actually, trial and error. And for this, are like kind of basically the cylinder part, which is really specific to cylinders, and the rest of them are actually some really basic topics specific to OpenGL and the buffer and other stuffs that we are going to talk in part 2. So if you're also interested to finish the whole process, then you can check it out. And I'll link the source code in the comment down below. You can go check it out, and I hope this is helpful, and see you in another one.